Okay. Welcome back, everybody. I hope had a good short break. And so let's dive into cross-site scripting. And so yeah, the subtitle kind of for that is I know you now. So cross-site scripting, XSS, is also known as cross-site scripting. It's widely known as XSS, but the abbreviation for that is cross-site scripting. And so cross-site scripting is essentially a method where attackers, they'll be able to inject like client-side script. So they'll not be able to directly manipulate the server side, because the server side script is not visible to any of the client, but they'll be able to inject client-side scripts such that it can make it can manipulate the server side as well. So this is essentially the main issue that pops up is due to unsanitization or not escaping of the input. Since they are not escaping the input or they're not sanitizing, it takes place. And this is a problem every time not sanitizing. So like though XSS attacks are possible in VB script, it's possible in ActiveX, it's possible in Flash, it's possible even in CSS. Yes, CSS, cascading style sheets, it's possible even in that. But they are more prominent in JavaScript, and that's what it's known for. So anytime you talk to any security personnel about XSS, they're gonna usually levitate to JavaScript, though they would probably know more about that it's possible elsewhere, but usually in the security world, it's within JavaScript, prominently JavaScript. And it is also useful in like several ways where you can like use it to steal the cookies of another user so that you can log in as that user and you can perform functions that the user has the permissions or the access to perform. And you can also perform several actions as somebody else without even logging in as them. So there are many things that you can do that way too. So to better understand XSS, we need to first understand what cookies are, because cookies play a very important role in XSS and the upcoming topics as well, like Csrf and SSRF, and they're like pretty important because cookies are usually just state variables. They store the state and they store the authentication of who the person is. So it is also a mechanism for the server to identify you. So if you say you are so and so, how does the server know that you are so and so, right? You're obviously going to pass in your password and your username, but what if a user has already? What if like somebody else logs into logs into the same system? How will they know that it is this person or that person? So for that, it's essentially cookies help out, and cookies are just key value pairs. So the key is usually going to be the name of the cookie, and the value is going to be value of what you want the cookie to be. So essentially, you could say the key could be like admin, just the admin as the name of the cookie, and the value could be either 0 or 1, like a Boolean value. So for example, if the admin cookie is set to 0, then the person is not an admin. They'll not have admin privileges. They'll not have admin rights. But if the user's cookie, admin cookie is set to 1, then they have admin privileges. So the issue with this is, since the server sends back the cookie, the users or the attackers, they are able to manipulate the cookie. And suppose if the cookie is set to 0, they are able to change it to 1 and thereby gain access to admin privileges. So that is also a thing called IDOR, which is similar to this. It's actually called insecure object deserialization. Deserialization of objects. So that IDOR is essentially just when you're changing the ID. So let's say that there are 100 users in a system, in a web app, and let's say that the 0th user is number 0, is the admin, and then from 1 there are different users. So user number 1 is maybe me, user number 2 is someone else, user number 3 is another person. So our IDs will be set to 1, 2, 3 based on who we are. But what if we're able to change those IDs? What if I'm able to change that ID from 1 to 0, right? Then I'll essentially be the admin, right? So that is IDOR, which is kind of close to cross-site scripting, but it's not exactly cross-site scripting, because we'll not be manipulating the entire client-side manipulation, because it doesn't happen only in JavaScript. It happens in different type of application, PHP, even in Python web servers. So it can take place anywhere. But yeah, so cookies can be implemented in several ways. Cookies can be set within the session. We call the session cookie. And sometimes within Python Flask applications, they can be also encoded, and they can be mapped with the actual data that the server stores. So the server might be storing some kind of data related to the user. And within that data, we are even adding the cookie. So it can be any way, right? And usually, how do we know that there is a cookie set? Is when you get the response from the server, there is usually this set cookie header. So whenever the set cookie header is present, we know that there is a cookie that is set there. But sometimes without the set cookie header, we can also set our own cookies by setting our cookies in PHP. You can do set cookie, and you can even delete your cookies. And there are so many operations you can do with cookies, but we're just going to go through that. So cookies are usually sent with every HTTP request for the domain they correspond to. So for every request that you send to the server, if the server is configured to add on cookies, it's going to send, for every request you send, the server is going to send back cookies to you. And once the cookie is set in your browser, in your client side, you don't really need to receive the cookie that the server is continually sending. You can just use the same. So your browser stores your cookies, and you would have heard that, like sometimes when you go to different websites, it asks, do you want to allow cookies? So when cookies are already set in your browser, the next time you log into the web page or you go into that page, it can retrieve your profile settings, or what are your previous footsteps that you had in that website. If you maybe made some changes in the website, then all that can be retrieved using the cookies. So this is essentially how cookies work. So when HTTP request is sent from a web client to the web server, the server sends back an HTTP response with the set cookie field. So the cookie is set and the web client receives it. So next time when the client sends a request, it just sends a HTTP request and the cookie. So this way the client says that you've already sent me a cookie and I'm this person, so now you identify me. So once the web server receives the cookie, it's like, okay, I got this cookie, and I know that I've already set this cookie before for this web client, or for this system, for this computer, for this IP address. So now I know that this IP address corresponds to this cookie, and it's this person who's sending this request to me. And if that person's cookie has access to the data that they're requesting, then the web server will provide the data back to that web client, just as an HTTP response. So since it already got the cookie back, it's not going to send the set cookie header anymore. And next, so we're going to get into XSS. We're going to get into pretty deep of XSS. I'm not going to, obviously there's going to be practicals for XSS as well that I'm going to show, but I'm not going to go too deep, again, because of the time constraints, but there is a lot more stuff that I've planned. Let's see how much we can reach within the given time. So as the name suggests, the user input gets reflected. So it can get reflected in several different places. And reflected XSS, the first type of cross-site scripting is reflected XSS. And it can get reflected either into an attribute of an HTML tag, or it could get reflected directly in the HTML page itself, or into some JavaScript context. So I'll explain that in a better sense. Let's say we have an image tag. And for that image tag, we have an attribute, for example, on load. So when the image loads, we are going to give some function for it to perform. So if there, within the onload attribute, if the attacker was able to provide an XSS, like suppose they were able to provide saying, get this document's cookie, they were able to provide a code saying, get this document's cookie, then it's going to get reflected, and it's going to get the document, it's going to get the cookie of that user. Similarly, into the HTML page, what if the attacker just wants to give an image tag without the attribute on load, but still wants to load some other page, right, or some other content? Then what they can do is they can give in the source. So they'll just give image load in the source, like in the source, they'll just load their malicious website. Or they could give a script tag. They could create their own functions. That is where JavaScript context comes in. So usually what attackers do is they give their own opening script tag and closing script tag, and then they give their own script inside that. They give their own function. So since JavaScript, most of the applications today run on JavaScript. JavaScript is really very hard for users to kind of sanitize, because there is so many things in JavaScript that needs to be sanitized. And so when attackers lay their hands on some kind of issue that the developer might have left out, they have a field day on that. So in this case, the user input does not get stored into database, but is rather reflected on the page itself. So this is very important. Reflected XSS is different from other types of XSS because the data that the user inputs, or the payload that the user gives in to exploit, it does not get stored in the database. It's like the basic SQL injection that we studied about. Does not get stored in the database, it just gets reflected on the web page. So how to test for reflected XSS? How do we test? How do we find out if reflected XSS is present or not, right? So for that, we have to test every endpoint, just as we did with SQL injection. We tested the username field, we tested the password field, and we also tested the URL, right? So like that, every endpoint or every entry point that we see where it is maybe a potential point where we could perform XSS, we have to test it all. And you can even try submitting random values to some fields to see how it reacts. So more of pen testing and web security is all about testing stuff out and seeing how it reacts to each of your input. It's kind of like stress testing and all the testing that the users and developers do, but it's from a security perspective and security standpoint. Then we have to determine the reflection context. So that's essentially where it is getting reflected. Like we spoke about, is it getting reflected in the JavaScript code, or is it getting reflected in the HTML page, or is it getting reflected in the HTML tag, attribute of HTML tag, how it is getting reflected. And we should also test the payload based on the location the value is reflected in. So that's essentially we have several different components to a web page. Like we'll have the header, we'll have the footer, we'll have the body. And so the body we'll have maybe a separate section. We might have different sections, or we might have several image tags, and we may have many other things inside the web page. So we need to also identify where the XSS is exactly being reflected. Is it being reflected within that image tag specifically, or is it being reflected in this entire column? Or is it being reflected in the entire sub column, or where it is being reflected? We need to find that out. And we need to continuously test several different payloads, because one payload which might work in one instance or one environment may not work in the same in another environment which looks the same. That will essentially be because the backend or the server side is going to be totally different from what you expect. Maybe in the front end it all looks the same. Maybe you just have a login screen, or maybe you just have a form that you have to submit. But in the server's end, there is going to be different changes. There's going to be some server code that's going to be changing. There's going to be the programming language that might be different. So everything plays a key role, and it's really important to again be patient even in XSS. So next, so here are a few examples of reflected XSS. The most basic type of example, again I'll show the practicals later after this, but the most basic type of XSS payload is this one over here. So you just type in script type equal to text slash JavaScript alert document.domain close script. So this is an there have been several iterations of this. This is like you can just type in script. You don't need the type variable over here, the type attribute. You don't need that. It's not really required. You can just type in script. We're just giving it there as a fail-safe mechanism, just if suppose the website does not understand, just for that. But usually it understands, so we can just give in script and close the tag without the type text JavaScript. Then alert is essentially an alert box that pops up. So it just pops up like a box with the data that is within this quotes over here, or within this brackets over here. So let's say document or domain. So document is essentially the web page or the website. The web page is a document that is being referred to here in JavaScript. If you would have some experience with JavaScript, you would understand the document is a web page. And domain is essentially the google.com, or if it's like essentially just the domain of the web page. So if it's going to be nyu.com or nyu.org or annauniversity.edu, so that's going to be over here. And then we're going to close the script tag. So this we'll be putting it in an input field, and when we test it, if an alert box appears with the information that is inside these braces, then we know that reflect XSS is possible over there, right? So this will execute the JavaScript inside the script tags. So within the script tag, we're giving JavaScript function, which is alert, and that'll be executed. So here we come to a very important thing. We will not be able to find such simple XSS vulnerabilities in web applications in 2022. So XSS has been there for a long time, since the inception of JavaScript and even like VB script and everything. So it's kind of the security landscape has kind of evolved, and even the developers who are developing, they kind of have some knowledge on how to mitigate these XSS vulnerabilities. And so such simple XSS vulnerabilities will not be available. But this is not to say that complex XSS vulnerabilities are not still available, because complex XSS vulnerabilities are available a lot, and the reason they're called complex is because it's pretty hard to find them. There have been sites which have gone years without anybody finding an XSS, just for some random person to find an XSS out of a sudden, because they tried some random payload. So it happens. There is no secure 100% secure website, but as much as we can, we have to try to secure them. So these are a few of the payloads that we can try nowadays to kind of get this basic kind of alert to work. So if you see here, I'll first talk about this. So if you see here, they're just using an A tag. A tag is essentially just a link tag in Java, in HTML. So if you see here, they're giving href. Href is the link, and inside that we're giving JavaScript, and we're giving it as alert. So we're giving this JavaScript over here, and then giving another JavaScript over here, so that if there is a web application firewall that scans for JavaScript and removes it, it's going to scan and find the first JavaScript and remove it. But it's going to leave the second JavaScript over here. So since the second JavaScript is all over here, it is still going to make this alert functionable. That's why we have two JavaScripts over here. Since if the web application firewall scans for the first iteration of JavaScript and removes it, then even though this JavaScript goes away, this JavaScript is still going to be there, and this alert will still be executed in the page. And that's going to happen when the user clicks on this test, because this is an href link to this. So when the user clicks on this test link, then the JavaScript alert is going to pop up, and we can see that that's a reflected XSS. Similarly, over here, we have this within script tags. So within script tags, again, we are giving our own function. We are declaring our own function, which is an error function, reference error prototype function. So it's gonna wait, and it's gonna alert this JavaScript alert box every time that there is the name. So there is essentially a name parameter that is being used on the web page. So every time that this name is executed on the web page, it's going to execute the function, and it's going to pop up an alert window. So you can also automate this by using a payload list from GitHub with the help of Burp Suite. So again, Burp Suite comes in to help everywhere. You can get several payload lists like this from GitHub. You can search on Google for your own XSS payload list, and you can just use Burp Suite to kind of like automate this. Or again, you can also build your Python program, which again requires some time and dedication to build the program. And exploitation of reflected XSS, just as I showed in the previous page. I'm just talking about a few examples, like how do you steal cookies, how do you redirect it from one page to another, and how do you deface the website. So stealing cookies is like the most basic. All we're going to do is we're going to write script tags, and then within the script tag, we're going to give a new image. We're going to create a new image. So we're just creating an image tag, but within the JavaScript tags. So we're creating a new image tag, but within JavaScript. So we're creating new image dot source, and so this HTTP link over here, this bogus.php, this is going to be our own exploit server. So we need to be running a server on our end, a local server, or maybe a remote server that we are just running on our end, so that when this uh, website is hit, when this endpoint is hit, then this document.cookie from the user's website is taken and sent to this HTTP 192.168.149.128. So just so that we can get the user's cookie to our website, so that we can steal it to our website, we need to be running a server over here. Let's say that there is a website where the user is able to update their password or update their name or something, and there is this script tag within that. We put this and we send it to them. So when this image loads in their web page, then this bogus.php site will receive the document.cookie as soon as it loads, because it's an image. As soon as it loads, this gets executed. So document.cookie from the user's cookie is fetched from the user's web page. Web page document is essentially a web page. It's fetched from them and it is sent to this endpoint. That's how you can steal cookies. So another issue with stealing cookies pops up with CSP, content security policy. So content security policy is another big thing when it comes to security of web pages, because content security policy has a few rules which, when you write it on your server, then it'll make it much harder for different domains. So attackers who have different, for example, this 192, 168, 149, 128 will not be accepted in a web page at all. So if they set their CSP to only accept Google links, then this link will not be accepted at all. And if they set their CSP to not accept any link, then any link you provide here will not be accepted. Like there are ways to overcome that and to go through that, but it's pretty complex. So again, we'll just like look at the basic stuff for now. So next is open redirection. Open redirection is pretty simple. All we're going to do is we're going to type in a script so that when the page loads, the user is not in that same page and taken to the attacker's website. So let's say, for example, there is a bank page, right? And we put this script in. So as soon as the page loads, it is taken to our website. And let's say that our website looks almost similar like the bank page. Then the user will think that's a bank page and enter their details, their password, everything over there. The next is defacement. Defacement is again another simple thing. We're just gonna touch upon the CSS. So we're just using script tags and document.body.background, and we're changing the colors or the image URL, and we can mess with it however we want. This defacement. Again, this is reflected XSS, which we are just doing on our end. Nothing is being stored in the database. All of this is happening in real time. Next, when we go ahead, we'll understand more how stored XSS works. So as you can see here, stored XSS, as the name suggests, the user input is stored in the servers. It can be stored maybe in the server's system, or it can be stored in the server's database, or maybe in a server's third-party applications that they're using anywhere, right? But it is also more dangerous and rarer as well compared to reflective XSS. So it's harder to find stored XSS than reflective XSS. So we've already seen that reflected XSS itself in 2022 is kind of hard to find, but stored XSS is much harder. It takes a lot of effort, a lot of time, a lot of time essentially. And the good part about this is that it does not need user interaction. So when you are storing an XSS, you don't need to continuously go and keep looking at it or keep doing something for it. So once it's stored, any user, even including the admin user, who looks at the data that is the payload that you stored, it will get activated every time they look at it. So every time they visit it or every time they look at it, then it'll every time execute and send us the if you're collecting their cookies, every time a user looks at it, cookies will be coming to us. And even more dangerous in areas where users can have higher privileges. So this is really important. If suppose you don't have enough privilege, but another user has higher privilege, and you're using stored XSS, And that higher privilege user kind of visits the page where the stored access is available or views that stored access is. And it becomes very devastating because they can be attacked by it. And once they're attacked, if you're smart enough to get their cookies, or if you're smart enough to get their password or something, then you'll be able to log in as them and wreak havoc on the website. So this again occurs when stored input is not sanitized properly. So even though you sanitize your input that is coming in, but if you're not storing it properly, if you're not storing it sanitized, then again it's an issue. So the issue does not just happen when you're taking in data, but it also happens how you're storing the data. So you have to sanitize, or you have to escape all your stored data as well. And the next thing is testing for stored access. So how do we test for stored access, right? So again, similar to reflected XSS, we're going to detect all the input fields. We're going to test our payloads in every single parameter. Because sometimes stored XSS is similar to like the blind SQL injection, where we cannot immediately see the results, but there will be some kind of indicators that something is taking place in the backend. Something is going wrong, or we've messed up something in the backend. That's always going to happen. Another important kind of tip is to analyze the HTML code. So HTML code is very important. It seems simple. HTML code seems simple. It's just something that we probably read every now and then. But it's very important that we analyze the code and we understand the code so that we know what kind of payload we need to give for each of the fields or for that specific page. And all data must be tested by inserting payloads and viewing them. So since it's stored XSS, we need to be able to view the payload that we have put in. Only then we'll know if it works or not. If we just put it out of hope and we never tested it out, we were never able to view it, we are not sure that it actually worked, right? And it can also be used on file upload if the name of the file is vulnerable. So this is another very important kind of vulnerability that have been exploited for a long time. File uploads have been the uh, play area to say for a lot of hackers, a lot of threat actors and attackers, because file uploads are usually overlooked. People tend to overlook them. They provide the basic security functionalities but overlook it. They don't go too deep into securing them, and since that is the case, stored XSS is like very easy when it comes to file uploads. And so before we head on to DOM XSS, so stored XSS again can be done in all these ways that is shown over here: stealing cookies, open redirection, defacement. But given that it is stored in the database or in the server, so let's say there's a comments page, and the comments page you're typing in a comment, and within the comment, if you put this, and if it's stored, then that means it's any user who comes and looks at the comment page, this will be executed for them, essentially. So you'll be getting all their cookies. So that's how it works. From reflected XSS, we're going to use the same kind of methods. We're going to use the same kind of payloads, just level it up a bit so that we are able to store it somewhere. And so anybody views that is under fire from us. So next is DOM-based XSS. DOM stands for Document Object Model. So document object model is essentially the website and all the parts of the website. It includes the tags, it includes the images, it includes the media that you've put on the website. Everything comes under document object model. And document object model helps you access any specific part of the website as well, specifically. And DOM also goes one step behind the source code of the web page, and it identifies how the website is built on a whole, from the structure to the what JavaScript version it's using, what kind of structure that is being followed for the templates, and every single thing is controlled by the DOM, and you can manipulate it, right? It occurs as a result of the attacker modifying the DOM environment, like I said. So the document object model, if the attacker tries to manipulate it, and if they are successful in manipulating it, then it's going to occur. Again, it's a client side, not a server side thing. The client side code runs in an unexpected manner. That's what we're trying to do. We're going to try to make it run in a way that it's advantageous for us, but not for the creators of the website. and testing for DOM-based XSS. So how do we do that? So essentially, DOM-based XSS works on this concept called sinks. So source and sinks, actually two things, source and sinks. So I'll explain what it is better. So if you see here, test by entering values in every single document source. So source is where you're going to test, where you're going to give an input and you're going to test. So an example would be like location.search or location dot replace. So those are all sources where you can input something. And then the sink is when the user uses developer tools to look at locations where the sink is being referenced. So for example, it'll be something like this that you see here. It'll look like x is equal to document dot location, right? So you see here location dot search is a source and document dot location is a sink because it is being stored in a variable. So source is essentially where what operation we are inputting into, and sink is essentially where the payload that you're inputting is landing. So I'm inputting into location.search my payload, but it's landing finally in variable x. So that is a sink. Then look everywhere where the variable is being used. You should look everywhere where it's being used, and if it's again being passed into some other sink, where it is being passed, we should again look at that. Then we can apply a regular XSS routine. So again, like we said over here, stealing cookies, open interaction, defacement, we can apply all of these. But we should identify what the source and what the sink is for DOM-based XSS, because that is what it's based on. And yeah, now let's head to the practical for this one. It's a pretty simple practical. I'm just going to show a basic cross-site scripting vulnerability. So to solve the lab, perform a cross-site scripting attack that calls the alert function. So like I already said, we need to call the alert function. And if we are able to call the alert function, then we get a reflected XSS. It's as simple as that. So I have two other practicals as well for this. So we'll be able to. So again, if you want to follow along, I can paste the, if you in the break, if you had probably had the time to create an account, I can paste this link over here. And it's in the chat box. So I'm just going to go ahead and so if we see here, there is home and there is no other, there's no my account or anything like we had before. We just have like an image that says we like to blog. And if we go down, we have something like view post. We go here, we have comment section, cool. And so we have posts like that. So we've seen, so there is one form entry over here and we have another form entry over here. So we can try first over here. So what we have to do here is we have to get the script alert. So we're just going to type in script. And like I said, if you want, you can give type is equal to text/JavaScript, but it's not really required. It's just a precaution or something like that, which we're just having a failsafe. And within the alert, you can give any data you want. I can even give document.domain if you want. And we're going to close that, and then we're going to close script. So when I hit search, as you can see, it's going to pop up. So this is the domain of the document over here. I can even give document dot, if I'm going to type script, I can maybe even give document.cookie to just show you. So there is no cookie stored over here. And if you want to see the cookie of like if you want to try the document.cookie, and if you want to see the cookie website as a cookie, you can just type here. You can just click on your URL. You can type JavaScript colon, and you can type in document.domain or document.cookie or whatever you'd want. So again, as you see, the document.domain is shown over here. This is the same document.domain we got over here when we searched. that we get over here. So that's just a basic cross-site scripting. And next we can head over to the next one, the next practical. This is a little bit advanced. So this lab contains reflected cross-site scripting in the search block functionality, where angle brackets are HTML encoded. To solve this lab, perform a cross-site scripting attack, injects an attribute, and calls the alert function. So this time the angle brackets are HTML encoded. So we cannot just type script and expect it to work. That's not going to happen, as I'll show now. And I'll copy this and send this in the chat as well. I hope you would have received that. So if you see here again, we know that it's in the search functionality because it's said in the description in the search functionality. So we don't have to worry about anything else. Let's type our usual script and let's see if that works. Document.cookie and close the script tag. And I hit enter. It's loading, but does not seem to work. So as you can see over here, the script tag just came in a script tag, right? Just came in a script tag. So we're not able to do this. So now we can try searching for single quote, double quotes to see how it works. Okay, so when we give single quote, it gives us double quotes over here, single quote and double quote. So it's 3. So we know that when it gives single quotes, it's being thrown off. So there is something going on there. So you can try with double quotes. What happens if you try with double quotes? We can see it shows 0 results. So that means that double quotes is being used over here and it's actually closing. So that means the query essentially on the other hand has maybe something like select star. I'm not saying it's select star, but I'm just giving this as an example from something, and then it has double quotes, and so it has a dollar search over here. So this is how it probably is. So when we give double quotes, it's just for dollar search, when we give double quotes, it's just closing like this and nothing, it's not returning anything. So now we know that double quotes is there. But now what we can do, another thing is always it's important to inspect a page. You can either go and look in the page source, view page source, or you can inspect it. Inspect this is much better because it's kind of like live. I just like it better. But as you can see here, it just shows us that there's a search and we have something set as value over here. And we have double quotes over here. So now what we're going to do is we're going to try, we see that with double quotes, it's closing it. So we can try a JavaScript functionality or a JavaScript attribute that's essentially called on mouse over equal to, and this time we're closing that and we're giving alert. So we can give alert 1 or we can give 0 or whatever we want, right? Anything. And now when we hit search, we see that again nothing happened, right? It's just showing on mouse over equal to alert. But now when I take my mouse and hover it above the search box, see what happens? It executes and it shows. So every time I hover above, it's going to execute. Hover above, it's going to execute. Hover above, it's going to execute. So that's where this attribute on mouse over or this tag attribute on mouse over works, and it provides this. So again, I can go back to home and I can maybe type in something else similar to that. On like on mouse over, there is even on load we could try, or there is on click, and there's so many other things we could try. But so we just saw that this practical works as well. It's pretty simple. We tested it with double quotes and we saw that it enters empty, it provides us an empty result. So all we did was we just used on mouse over and we saw that it works. So the next one that we're going to look at is practical number 3. So this one is going to be a pretty big practical, complex one actually. I'll paste this into the chat as well. And for this, we'll essentially be using Burp Suite. For this lab, I need to use Burp Suite because like I need an exploit server. Like I said that we sometimes require servers to steal cookies because we're going to steal cookies over here. But since I don't have a server setup, I'm just going to use Burp Suite, which has its own server. Burp Suite has this option called Burp Collaborator, which is only present in like the pro version. So since I have the pro version over here, I'm just gonna use the Burp Collaborator client. And so once if you have the Burp Pro, all you have to do is open your Burp client. If you do not have a Burp client, you can just go to this site called webhook.site, which will give you a separate webhook like this online. So you don't need to create your own server. You can just use this webhook. So I can use a webhook in this or Burp Collaborator, whichever works. I'll show you in both. Maybe I'll first show in Burp Collaborator and then maybe show over here. So I'm just going to access the lab now. And so it asks us to exfiltrate the victim's session cookie. I should have read that. So the lab contains a stored XSS vulnerability in the blog comments function. So within the blog comments function, there is a stored XSS vulnerability. So let's go ahead. So we know that there is no search over here. So we have to go to the blog itself. And there's a comment option over here. So it said that within this comment, the stored XSS is possible. So we can try a basic one. Let's just try script alert and O or 0 and just close the script tag and given some random name, an email and a website and post it. So comment has been submitted. When we go back to the blog, you see it executes. So yeah, stored XSS is possible. So now what we can do is we can try giving our own XSS over here. So for so this was my comment that I gave, the name that I said. So now what we have to do is we have to steal our cookies. So to steal the cookies, what we have to do is we need to link to this Burp Collaborator link I have over here, this server link. So for that, we'll be using operation called fetch, as you can see over here. So within script, I'll just copy this. I have it ready because it'll take a while to type. So I'll just show it over here, what it means essentially. So if you see again, we have the open script tag, we have the close script tag, and then we have the fetch operation. So the fetch operation, all that we're doing over here is we're giving our Burp Collaborators link or the webhook link, whichever you're doing. So I'll be giving my Burp Collaborators link. I'm just going to copy it. I'm going to go and I'm going to give that link over here. And then we're setting the method as post because this comment form is being passed as a post. If you can see over here, it says post. And then we are setting the mode to no cross origin. So cross origin policy is another big topic. Let's just say that it involves adding resources from different websites or from different origins or domains. So we are allowing that. And we're setting the body as document.cookie. So in the body, we'll get the cookie for this whoever views this page. And again, name, I'm just going to give some random name, and email, again a random email, and the website as well, a random website, just like that. So now if I post a comment, so if you see over here, till now there is no result that has popped up here in Burp, but once I post it and I go over here and I hit poll now, it's taking a while, but you can see that there is a DNS, and HTTP query. So now when I go back to the blog, this I already set this first, so it's just popping up. And you can see that indeed my post has been made. And so when I go here, I can see that there's an HTTP call, right? An HTTP request that was sent. So when I click on this and I go to the request and I go down, I see that the cookie has been set in the body. We wanted the cookie to be in the body, and now it's there in the body of the request. So we have that. So you can also see the response. So this is essentially just the cookie. So if we see over here, we have the secret and session, and we have this again over here. So now what we have to do is we just have to copy this, and we can head over to this my account page. And over here, we haven't logged in yet. Just see that we haven't logged in yet. Make sure we haven't logged in yet. But now what we're going to do is we're going to go use a tool or an extension that's called as cookie editor. You can just, if you have Chrome, you can download it. It's called cookie editor. I'm going to delete all the previous cookies that was there, and I'm going to add my cookie now. So I'm going to take this away. I'm just going to first add the secret cookie, the name secret, and because that is a name and cookie is a name value pair. So I'm going to add this over here, and then I'm going to add the next one, that is the session. So I'm going to take all of this and this away because it's a name, and all of this away, session. And now all I have to do, since it's set, is reload it. And so it says that I've solved the lab. So that's how much of it we'll be able to get the cookie, and then we'll be able to set it up. So that was the third practical, that we were able to steal the cookies. So whoever went to that page, if I again go to the blog page, if I go inside, again it's gonna show up, and again the cookie will be passed in. So since I've already so if you can see here, again when I repeated it, it again brought the cookie to me. So that's about it as much as this Burp Collaborator is concerned. And similarly, the same thing can be done with webhook.site as well. It's the same thing. So if we go to home and we head over to the post, and we take our script or our payload and we paste it there. So go here and we paste it here. And so we need to give our address over here. So I'm just going to take this, I'm going to copy this from here, go here and give this here. So as you can see, I've given this here. Now I can give again some random name, email ID, and website, and post a comment. It has been done, but my request hasn't come here yet because I haven't seen that yet. And when I go here and when I click Naveen, it should pop up over here, and it doesn't seem to work. I might have made a mistake. Okay, so essentially this uses only GET requests. I see what has gone wrong. So this URL, this webhook over here, just uses GET requests, and I need to upgrade to use the post version. And yeah, so if you're good to upgrade, you can use the post version, but otherwise it's easier to use Burp. Burp has always been the best tool out there for any of your cross-site scripting or SQL injection or any needs. So I'd recommend using Burp. There's also a free trial version for Burp that you can get free for 30 days. So if you just go to Burp Suite's website, you can get it for 30 days. So I recommend using that. Let's move on to our next topic. that is cross-site request forgery. So after XSS, cross-site request forgery is another important topic when it comes to web application security. And you'll understand why it is pretty important. So CSRF, shortly known, instead of cross-site request forgery, is an attack technique that attempts to go beyond, or like that attempts to kind of overcome the technique that is a defensive technique that is used as CSRF tokens. So there's something called CSRF tokens, and these CSRF tokens are something that does not allow direct access to the user's assets. So I'll just explain it with this simple example that I wrote here. Okay, so let's say that we just launched our own real estate website. It's a new website that we just launched, and in that website we have a profile section where the users have the ability that they can update their address. Okay, let's say that an attacker is able to analyze the request and forge it. Let's say that that the update request, the post request or get request for the update, the attacker is able to look into it and forge it. So what the attacker does, what does it mean by the attacker analyzing and forging it? So the attacker essentially creates their own website, and in that website they have a button. So when the user is clicking on that button, it calls to the profile section of our website and updates the address, right? So what is going to do the button? It's going to send a post request to our website to update the address. This means the attacker can update a user's address from their own website. They don't need to go to our website and then make the user click. They don't need to do XSS that way. All they need to do is they need to set up their own website with a button and put in our website's code, our website's address into that with a post request to update the address. So this may seem pretty innocent, but what if, right? If instead of a real estate website, what if it is a bank website? What if the attacker can, send money from our account to his account or her account? Or what if the attacker could change our details? What if the attacker was able to get our credit card details, right? That would be very, very dangerous, right? So to prevent this, the CSRF tokens were introduced or implemented. So CSRF token is essentially a server-side generated token. It's not client-side like cookies. So cookies are usually generated in the server side, but they are stored in client side. But the thing with CSRF tokens that it's visible to the browser only through the website, right? It's not stored. It's something that is sent from the server, but isn't stored just like the cookies. So as an attacker, we can't actually directly gain access to this token, because it's not visible to us. But there are some ways that we can use to gain access to the token. So now if the attacker wants to make that same request, the request wouldn't be happening because this time the CSRF token is not present in the attacker's request, right? So let's go ahead and I'll show you this practical for this. So this is essentially the practical for CSRF. So we are essentially going to do XSS and CSRF together in this, not just basic CSRF. So I'll put the link in the chat if you want to follow along. And for this as well, we need Burp Suite. So just make sure that you have Burp Suite installed if you want to follow along, and we can just go ahead. So CSRF vulnerability so this has no defenses. It just has the basic CSRF token set, like the cookies. No CSRF token set yet. This lab's email change functionality is vulnerable to CSRF. Okay, so the email change vulnerabilities functionality is vulnerable. And to solve this lab, we have to craft some HTML that uses CSRF attack to change the viewer's email address and upload it to our exploit server, right? So to our exploit server, we have a separate server where the user's viewer's email address is changed and uploaded. So now we can log into our own account using the credentials, Wiener and Peter. So let's go ahead and access the lab. So we know that the email change functionality is where we have to attack. And I'm going to go to my account. I have the credentials to that, ENER, and it's Peter here. So I'm just going to log in. And now you see that the email is set to wiener@normal-user.net, right, for Wiener Beta. So now what we have to do is we have to be able to generate our own Csrf payload such that this email, whoever accesses that link, the Csrf that we generate, whenever they access it, their email will be changed to what we want it to be, right? So for this, we cannot just do this over here. We need to be able to do this in tandem with the Burp Suite. So in Burp Suite, what I'm going to do is I'm just going to go open Burp Suite's embedded browser. That opens up here. And I'm going to copy this link and use it over there. Burp Suite's browser. And okay. So I'm going to access the lab from here. So this way, now after I log in, I have to capture the data, the request actually. So as you can see here, I have, so this was the other website. I don't need that. I just need this. So as you can see here, it's logged in already, right? So I have my burp suite open here, and I'm going to switch on my intercept because I want to intercept the request. So I'm just going to give in some random email over here, something like that. And okay, I'll just give in some random email now, dot something, and I'm going to hit update email. So when I hit update email, as you can see over here, this loads up over here, and I'm going to click on so I'm going to actually right click over here, and I'm going to go down all the way to engagement tools over here and click on generate Csrf POC, as you can see. So all I did was I switched on my intercept, gave some random email over here, clicked on update email, came back to my burp suite, right clicked here, went to engagement tools, generate Csrf POC. So once I click that, it's going to give me something over here like this. So first things first, I have to click on options, click on include auto submit script, so that the script is automatically submitted and the user does not need to click the button. And I'm going to give regenerate. And as you can see here, the form is submitted automatically. And here we can change the email address as what we want it to be. So I'm going to set the email address to be Stafford, and here I'm going to set it to be hacked, and here it's going to be you. So now when it's set like this, I just need to copy the HTML. And so since I don't have my exploit server set, I'm just going to use Burp Suite's own exploit server. I'm just going to use Burp Suite's own exploit server. And I'm going to go down, and in the body, I'm going to paste that what I copied. If you see over here. So now if I want to view the exploit, I'm just going to click view exploit. So it'll come like this. That is my account. And if you see here, Stafford@hack.u. It's pretty simple. So on the user's end, this will be their web page. And in their web page, they just have one button, which has a form action that goes to our Web Security Academy website. That is this website over here. Sorry, this website over here. It goes over here, this one over here. And it goes to change email. So that is a post request that is sent. And the email is set as hack.u. And this is the button where you submit. So when I see view exploit, submit request, as you can see, the name is changed. So I can change it to anything I want. If you see here, I can change this to I hacked you. So now when I click view exploit, it's going to show I hacked you. And I didn't need to click the button because we gave auto submit to the form. And finally, when this is ready, we can just say deliver exploit to victim. And that's just to complete our lab, to solve the lab. And that's about it. So, and that was like XSS. So we used two things here. We used our XSS knowledge as well that we had, right? And we used Csrf. So since there was no Csrf token over here, we could directly access it. But if Csrf tokens were there, things would have gotten more harder for us. But good thing that Csrf tokens weren't there. So once Csrf is done, I hope that was kind of understanding, like you could understand it and you could like make sense of what was being said, because we covered a lot of stuff today, from SQL injection to cross-site scripting to cross-site request forgery. And it does not end here, because there are so many more, like SSRF, server-side request forgery, and then there is BAC, broken access control, broken authentication, IDOR, like I said before, and there are like so many more vulnerabilities for web applications, but we just don't have enough time for that. So let's just head over to our next topic, that is mobile hacking. And so the subtitle for this is I know who you texted. So yeah. So mobile hacking, what is mobile hacking about, right? What is it? Like nowadays, we've come so far that our computers have just been shortened, or they've been minimized, and they've been reduced in size that we can hold them in our hands. Our smartphones are actually even more powerful than the computer that was sent to the moon. So we have a lot of power in our hands today. And mobile technology is something that is booming. And mobile technology is just a basic introduction, is a technology that was used for cellular communication. And so we have smartphones nowadays. We used to have handheld devices from before, but they weren't as smart to say. But now we have smartphones, and these smartphones run operating systems. They have their own operating systems that are being run on the smartphones. And as you all know, the most popular OSs are like Android OS. For Android devices, we have iOS. For Apple devices, and then latest, like right now, we have Harmony OS, which is Huawei's own operating system as well. And so we are mostly going to focus on Android operating systems. So for the explanation I'm going to give you now is just going to be an Android OS and how we're going to create a malware based application on Android OS. That's what we're going to talk about. And also, so just a basic introduction to Android OS, it's based on Linux kernel. So most of the Linux vulnerabilities, and also the Linux, the good stuff and the bad stuff about Linux also flows over to the Android OS. Following are the attack surfaces for mobiles: Bluetooth and Wi-Fi, cracked applications, root accesses, data-related attacks. So Bluetooth is an attack surface because if your Bluetooth is just left on randomly, and if another person is able to connect to your Bluetooth to your mobile, then they'll be able to send you some unwanted data or unwanted applications, or maybe they may be able to even retrieve data from your device. And the same way with Wi-Fi. So Wi-Fi has become a good thing and a menace, because if you're in the same public Wi-Fi, people are able to hack into your systems without you even knowing that they're doing it. And the next is cracked applications. So cracked applications play a major role in hacking mobiles, because cracked applications, you can create backdoors in them, you can create malwares, you can create viruses and bugs, and all of those can be just put into one cracked application and it can take down your entire phone. So the most common method for cracked applications is Metasploit, whereby using Metasploit, which is a command line tool, hackers are able to craft their own application, or even use applications that are available on Play Store, but inject their own code into it such that it becomes a vulnerable application, and they are able to monitor your mobile devices. They're able to watch what you're doing. They're able to send text from your devices. They're able to receive your text, get your data, and it's pretty scary too. Next is root access. So usually mobile phones do not have root access. Their super user permissions are blocked by the manufacturer, but there are options whereby the manufacturers also allow the users to unboot their devices, or they call it bootloader unlocking. That's essentially just gaining root access to your mobile device. Whereas like in systems and PCs, we have root access by default. That is not the case with mobile devices. And finally, there are also data-related attacks. So data-related attacks closely coincide with the cracked applications, because data-related attacks usually happen within the applications having some faults like buffer overflow, or some kind of memory corruption attacks, and all of those. So we're gonna look at Android hacking case study. So this is essentially just an article that I had written about. I thought that explaining it would make more sense, because that way you would all have access to the article. And so I'm just gonna go ahead to that article, and it's over here. Yeah, so this is kind of the article that I was trying to talk about. So you can read it later if you want the above, but I'm just going to go through what we're going to do in this and how I did it in I'm just going to give a gist of what I did over here. So malware is essentially any software that is intentionally designed to cause damage to any system, in this case a mobile device. And over here I just wanted to show and construct a malware from base up that is able to bring some severe damage to the system. Also, so what happens here is I'm going to extend a reverse shell to control the entire device, and there is going to be like the SMS message functionality in the device, from which I'm going to compromise the mobile to get an HTTP server access and store the database, and like essentially just gain access to the mobile device. So reverse shell access. So when I manipulate the application and I send it over, and if the application is installed on a person's mobile device, let's say, and then I'll be able to access the details on the mobile device, their databases, their WhatsApp contacts, their chat, and a lot more other stuff, right? So basically for this, what I'm going to do is I'm going to create a basic SMS app. And so I use the help of this GitHub repo to build the SMS app, because I'm not so good at Android coding, but kind of help that. And then also I used help. I kind of took the help of the Hacking Android book by Mohammad A. Imran and Srinivasa Rao Kotipalli. And so this malware is kind of different. It's like an SMS app, whereby if that's installed on the device, we have full access to the device. So let's see how we can get it set up. So essentially what we need for this is Android Studio. And that's essentially what you'll need. You don't really need any other applications or anything for it, but it's also good if you have EC2 instance, which will help us later on, where we can have our server to receive the data from the mobile, like our exploit server. Or you can just have another webhook like I showed from webhook. This one, but again, you have to pay for post requests, so that's there. And also, if you have some Android app building skill or knowledge, that's highly appreciated, because it helps a lot. So I'm just like, so to build the malware, I'm just creating a new project, and I'm naming it as a COVID-19 safety app, essentially that when it was COVID-19. And I selected the Java language, and I just entered this information, the activity main.xml. So I'll be sharing this link so that you'll be able to access this. Since there isn't enough time, I'm not going to go through the entire code. I'm just going to show you the basics of how it worked out. And you'll be able to read this, go through this article on your own so that you'll understand how everything is laid out. And I just gave a button which says text now, because it's an SMS messaging app, obviously. And I gave an image, another text view over there, don't risk the life of your loved ones. And then the code adds one button that I said over here, the text, and you can even give it background image if you want. It's again optional. And so now is where the important part comes in. So here is where the host IP over here, you need to replace this thing with your configured IP. I've used the IP of my EC2 instance. You can use the IP of your server, that your exploit server that you're setting up. So you'd have to use that IP here, and you have to give the port that your IP is listening on. I set it as 1337. Just leet. I couldn't stop myself from saying leet, so I just said it there. And I gave a message permission code to 100. 100 message permission code is important because that is what allows to send and receive messages to your host IP and host port. So this is, again, I'm saying this is a host IP of your exploit server. This is a host port of your exploit server on which it's listening. Next, under in your r.layout.activity main, we're setting a content view where our messages are not enabled. They're set as disabled by default. And we are also giving permission to read SMS for the application. And here is where we are giving the reverse shell function call. After this message set enabled, we're giving reverse shell function call. We haven't yet built this function yet, but we're just giving the function call there. And here, as you can see, again, this is just the background for how the message is sent and received. So we don't need to worry about that a lot. We can just go ahead. And here again, this is just the message stuff, the date, the time, the format, and everything. And after that, we are making sure that we have the permission for installing some applications that we want. We have the permission to read the messages. We have essentially a lot of permissions, which a normal SMS app will not have. And now we're creating reverse shell command. So this function, reverse shell function, we are giving it we are connecting it with the host address and then the host IP, as I said, and then the host port. We're creating a socket connection so that we can access the system.bin/sh of the phone and provide the tunnel to our server, right? So this way, after we've given all the permissions and we've given it the right operations and everything, now this is where I hosted my website or my server essentially. And if you can see here, I'm just showing how you can go and you can create your own website or your own hosting. And again, over here, I just show more on how you can create your own database. So why I'm creating this website is to create my own database where I can store all the details that I'm receiving from the mobile. So every detail from the mobile is sent to this database and it's stored in this database remotely. And now what I'm going to do is, yeah, so I'm just going to build the APK. And once the APK is built, and I'm going to start listening on my server. So if you see my Ubuntu server, like I said, the EC2 instance, I started my listener on port 1337, leet again. And so once the application is installed, this is how it looks. It looks like this. And once the users give the permission to allow SMS messages, this is how it looks. And then now we can see that we have a connection from, so this 49.37.223.116 is the IP of the mobile device. And this is the port of the mobile device where it has been connected from. And now we can type in several commands to test it out. For example, as you see over here, I typed in the ID, I got the ID of the mobile, and I got also df-h is essentially like list, and I got all the information that is there in the mobile over here. As you can see, the how much available memory, how much used memory, what is it mounted on. It's essentially just like our Linux kernel. As you see, since the mobile device has not been rooted, we cannot use the ls command and sudo command because sudo is not, we don't have root access to the mobile. So if the mobile is rooted, we'll have more and more functionalities where we can use sudo to perform a lot more havoc and change a lot more stuff. And again, as you can see here, we get all the data details. So this is their message, as you can see, all their message, who they sent it to, at what time, what is the phone number they received it from, and everything else. And that's about it. So as you can see here, the time and date that is being verified, I got this message on this date and this time, and that's being verified. And that's about it. So again, I've just given these files essentially what needs to be added. So this is essentially just another malware, how an Android mobile can be hacked using just one application that we created on our own and few permissions that we gave, and we were able to get reverse shell access. So how much more can a hacker who has more time, more resources, more knowledge in Android coding, how much more can a hacker do that? So with that, we come to the end of our session. I guess we're right on time. So yeah, thank you for staying this long and going all the way.
Thank you, Stafford. Is there any question related to this topic? You can post, test post. You can post the questions through chat box.
Yeah, I'm good with any questions you have, or if you even need the resources that I used, I'll probably talk with Kubran sir, and maybe he could make it available to all of you as well. So thank you.
So thank you all. Thank you, Stafford. It was a great session for you, and I think everyone enjoyed your presentation. So thank you all participants for patient listening. The Stafford is very passionate on cybersecurity. He worked a lot because I know him for a long time. And so if you have any queries, anything, I will share his contact detail. You can post your query and you can get clarified. So thank you, Stafford. It was an amazing session. And
Thank you,
on behalf of the CFD Anna University, the Engineering College, and on behalf of all the participants, once again, and thank you. We'll meet again. So thank you.
Thank you, sir. Thank you for the opportunity, sir. Thank you so much.
Thank you.